Okay, so in this video, we're going to take a look at the inverse sine and using a calculator to calculate values. Just a little refresher on our inverse sine function. Right? We know our domain, in other words, the input, the values of x, are -1, between -1 and 1 inclusively. And the range, the output, is some angle, right? Again, remember, always think of the inverse sine is a function that takes in some value between -1 and 1, right? The ratio of the arc length and the radius here. And then the output is some angle. In this case, for the inverse sine, the output is an angle between -π/2 and π/2. Okay, and then here are some properties, again here, stuff that we've calculated previously, right? Or that we've gone over in a previous module. The sine of the inverse sine of x is equal to x, again, inverse properties, but since these are trig functions, there are some conditions here, as long as x is between -1 and 1. And then the reverse, the inverse sine, the sine of x, is x if the angle falls between π/2 and -π/2. Okay, so again, just be very mindful of that. Right? One thing is, again, just an example here. We'll use degrees here for this example. Okay, that looks okay. All right. So we don't have to deal with decimals. Again, just simply a visual here. So if we look at second sine inverse, sine of 120 degrees. Okay. All right, now we see here, right, that 120 is outside the values for x here. So we are not going to get 120. Instead, what we do get is we get a value of 60. We get a value that does fall within that outside function, its range, right? -π/2 to π/2, right? This being π/3. Okay, so just keep that in mind when you're dealing with these inverse sines, right? This calculator, right, or any calculator in general, follows these guidelines, right, where this is our domain and that is our range. All right, your calculator is incredibly fast at doing calculations, but it's not very smart. It needs to be told exactly what to do, and you need to be able to interpret that. Okay, so let's do an example here. Right? Okay, so here, let's say that we have arc sine of negatives, -0.75. All right, and again, right, what this is asking for is what value of the sine function, what angle gives the value for the sine to be -0.75. Okay, again, the result of this is some angle beta. Okay, all right. So if I go ahead and calculate this, right, arc sine, this over here, I'm gonna switch over to radian mode, right? Second sine inverse of -0.75. Okay, so arc sine of -0.75, I get the value of -0.848. I'll go 3 decimal places. It's unclear how many we need. 2 is usually fine, but here I just want the extra decimal place. Okay, now what this is telling me is that the way I interpret this, again based off our formulation up here, that means that the sine of -0.848 is equal to -0.75. Okay, so in other words, this is our angle. All right, and that's how you would use a calculator to evaluate a function value for the sine of arc sine. Now, let's switch the problem up a little bit, right? Let's say that, well, what if I wanted to solve this problem, right? What if I was asked to find all the angles in the interval 0 to 2 pi. Yeah, this should be a parentheses, right? There's 0, 2 pi, then no need to include both of them. Just choose one, where sine of alpha is equal to negative 0.75. Well, we might be asking ourselves or mentioning, I think I already found one angle. And we did find an angle, right? We found negative 0.848, that being our angle in radians. There's a big problem though, right? That angle is not in this interval, right? This interval is in the positive direction, 1/4 rotation between 0 and 2 pi. Now, my angle is only, my calculator is going to continue giving me this value of 0.75, right? So, negative 0.75, negative 0.848. Right? So what do we do? Right. Well, here is where it is up to us to interpret this solution here, right? And what I know about the sine function where the angle falls between 0 and 2 pi. Okay, so first step here, again, I always like to draw myself a picture. All right, where is the sine negative? The sine is negative in quadrant 3 and quadrant 4. So I know I'm looking for two angles. Right? Let me change up the color here. I'll call one of them alpha 1, one in quadrant 3, and I'll call the other one alpha 2 in quadrant 4. Right? I'm looking for both of those angles. Right? Now the angle that I found, right, using the inverse sine here, is negative 0.848. Right. Now here is where my knowledge of reference angles is going to become very, very useful here. All right. Well, I know that if I call this one theta, right, if this is our angle theta, then theta reference, my reference angle, is the angle made, positive angle between the x-axis and the terminal side. All right, x-axis and the terminal side. So it's always positive. So my theta reference is going to be 0.848. Okay. All right. Now that's going to be helpful because seeing as how these are the values of the sine here, negative 0.75, that means that the angle measure here is the size of my theta r, my reference angle theta. And that is also the value of this side here, which means that alpha 1, right, if I look here, 1/2 rotation, that's pi. And how much further than pi do I go? Theta r. So alpha 1 is going to be pi plus theta r. And then alpha 2, now this one, I go all the way to 2 pi, but that's too much. By how much? By my reference angle. So that'll be 2 pi minus theta r. All right, and now it comes a matter of just plugging these values into my calculator. All right, so we get second pi plus 0.848, and we get a value of 3.990. Okay, if I use proper rounding techniques here, and we're going 3 decimal places, since that's what I started with. All right, so that'll be alpha 1. Alpha 2, we'll get 2 second pi minus 0.848. And that gives me 5.435. Right, and both of these fall in between 0 and 2 pi. Okay, so just keep in mind here, right? While the calculator is going to be useful in giving us that initial angle, it's going to be up to us to interpret it. All right, it won't be as simple as just reading most of the time. Sometimes it will, right? Or we just read the one in our calculator and then we do a little bit more work. But again, right, what's going to be helpful? Drawing yourself a picture, right, and our knowledge of reference angles. All right, let's do one more example here where the value is positive, right, and we'll see how that simplifies things a little bit. All right. Okay, so here, so let's say we had the arc, or here, let's do our, for this example, find all angles in the interval 0 to 2 pi, where the sine of theta is equal to 0.9. Okay. Okay, so in this case here, right, so if sine, using properties of our inverse, if sine of theta is equal to 0.9, that's if and only if arc sine of 0.9 is equal to theta. Okay, so taking my calculator out here, we have sine inverse of 0.9, and we get a value of 1.12. So here, all right. Okay, so let's look at what we found here. We have a positive angle. Now, because of the nature of the inverse sine, here we get an angle in the first quadrant when it's positive, right, between 0 and pi over 2. So that is our angle theta. Right, and I also found our first angle, right, theta 1. The value of the sine is 0.9. Theta 1 is equal to 1.12. Right, that one is right away. There's no adding or subtracting of pi or 2 pi in this case. Right, it's nice when it's quadrant 1, right, because there it's like right away. All right, I found it. Right, but again, right, we're not done. Right, here is where, right, we need to be able to interpret these results. Okay, all right. Now, excuse me. Now here, right, where else is the sign positive in between 0 and 2 pi? Well, that would be in quadrant 2. Right, so there's a second angle that I need to find. I'll call it theta 2. All right. Well, we're going to use that, but again, using reference angle theta r. Now, when it's in quadrant 1, theta is also theta r. It's also our reference angle. Okay. All right. So theta 2 is going to be, right, pi would be 1/4 or 1/2 revolution there, but that would be too much. By how many radians? By theta r. So I have to cut out or subtract theta r. Okay, so we have pi minus 1.12. Taking out my calculator. Oops. Pi minus 1.12. And we get a value of 2.02. That would be my theta 2. All right, and then those two quadrants, those are my two angles where the sign is positive. All right. Again, right, what I want to see from you guys when evaluating these sine inverses and you're asked questions like this, I want to see these drawings for yourself, right, and in your work as well, right? They're crucial, right? If you're gonna You're going to sit there, and without this, it's going to get very confused. I know it is for myself. If I don't have that, this just clears things up tremendously. Okay, thank you.